Hello everyone. In this video we're going to talk about the basic laws of exponents. So to your right on the top right hand corner you see eight, rather seven basic laws of exponents. Okay, so we're going to talk about each of them using the example. So let's say if we have x raised to the power of 2 times x raised to the power of 3. In order to simplify it and make it one base, x, instead of two with separate powers, we can combine these two bases with different powers into one base. So we're going to have one base. So which rule do you think we would use? Well, based on the rules provided, we're going to use the first rule, right? Because the first rule uh, lists a product of two bases with different powers, a and b, right? So we simply have one base x raised to the power of a plus b. So when we have the same base with different powers, we basically keep that base and add the respective powers together as its power. Okay, so we're going to have 2 plus 3. And that equals to x to the fifth, right? Okay, now let's try another example. Let's try 2 2x raised to the power of 2. Now, which rule does this resemble? Which rule does it refer to? Well, it's going to be not the first one, right? Because it looks like we have something in parentheses and we're squaring or raising to the power of a the product, right? And that's going to be this rule right here on the very top on the right. So xy raised to the power of a is equal to x raised to the power of a times y to the power of a. So basically, you split this product xy into individual bases x and y, and you apply that power that was meant for the product to each of these bases that you split. Okay, so basically what is going to be in this example is going to be 2 squared times x squared, and that is equal to 4x squared. Okay, so now let's try something else. Let's try, so we have to have 8 examples in order to work all of these laws. So let's try something like this. Let's try 4y squared raised to the power of 3. Okay, so now we're kind of combining two rules here. We're going to use this rule that we did for the previous example, this rule on the very top on the right, and we're going to use this rule now as well, right? Because we have a power already inside for the inside base, inside the parentheses. We already have a power, but we also have a power outside, right? So whatever the x as a base was raised to some power, we will also raise this result to a certain power as well. So based on this rule, we simply multiply the powers together. Okay, the one that was meant for the original base x and also the one that's meant outside of it. Okay, so it's going to be base x raised to the power of the product of the two powers. Okay, so in this case, we're going to apply this rule first by distributing the power of 3 to the 4 respectively. So we're going to have a 4 to the power of 3 multiplying the y to the power of 2 times 3, right? Because we have to multiply these powers together in this case. So as a result, we will have 16, well, 4 to the power of 3 is 64, and then y, and 2 times 3 is 6, right? So the result is 64y to the 6. Okay, that's the result. Let's try an interesting example. Let's try 2 over x taken to the power of 4. What is that going to give us? Which rule are we going to use? We're going to use this rule, right? X over y raised to the power of a. And this division works the same way, right? It works the same way as the multiplication one on the very top on the right here. You distribute the power of a to each of the bases, and you split the bases accordingly this way. X raised to the power of a divided by y raised to the power of a. So we're going to have 2 raised to the power of 4 divided by x to the power of 4. Okay, so you split the the numbers 2 and the x, okay? And you apply power 4 to them individually. So you will have 2 raised to the power 4, which is equal to 16 over x to the 4. Now, how do you express this result without the fraction? Okay, so without the fraction, you will have to use this rule. Let's see. You would have to understand that 1 over x is equal to x to the negative 1, right? So 16 over 16 over x to the fourth can be expressed as 16 times 1 over x to the fourth, and using this rule here, we will have 16 times x raised to the power of negative 4, right? And as a result, we get 16x negative 4. Okay, so that's a way to get rid of the fraction here. Okay, let's try something else. Let's say let's give a complicated case. Let's say if we have well, we don't need parentheses for this. Let's have 2 to the minus 2 over 3 to the minus 3. What is that going to give us? Well, which rule are we going to follow? We're going to follow this rule, right? Getting rid of the negative exponents and transforming them into the positive. But let's see how they get this result. Okay, let's use these numbers and show us how we would get this result. So the result should be this, right? It should be 3 to the power of 3 over 2 to the power of 2. But let's see how they do that. Let's use the existing laws that we have and arrive at this conclusion. So 2 raised to the power of negative 2 is basically saying 1 over 2 raised to the power of 2, right? And then that is divided by 1 over 3 raised to the power of 3. Okay, now when you divide the fractions, you will have to keep the first fraction, which is 1 over 2 squared, and then multiply and flip the second fraction, right? And you're going to have 3 raised to the power of 3. So as a result, you have 3 raised to the power of 3 over 2 raised to the power of 2. And that's exactly what the rule suggested for us to do. Okay, so it proves that it actually works this way. Okay, well, let's see. And for this reason, of course, it works. This rule works as well for the same reasons. Let's try to experiment a little bit. Let's have x over y raised to the power of negative 2. How would you do that? Well, it can be said that we could have x over y raised to the power of negative 2 times 1, right? We can do that. So now, which rule are we going to use to get this negative 2 inside? Well, we're going to use, which rule is that? We're going to use this one, right? Because we have a power inside the parentheses and the one outside. So we can take this negative 2 inside. So we're going to have x, and we're going to distribute, we're going to have, well, let's see, let's have this x over y to the negative 2 raised to the power of 1. And that's going to give us, and now we're going to apply this negative 2 to each of these variables, x and the y. So we're going to have x negative 2 over y negative 2 raised to the first power. And which rule did we use here? We used well, let's see. Okay, we use this rule on the top right hand corner. Okay, so we applied the power outside to each of the bases x and y. Okay, so in this case x and y, but they're well, actually this one precisely, this one we use this one, right? So we apply the a inside for both x and y separately. Okay, so x to the power of -2 over y to the power of -2. Let's get rid of this 1 because we know that that a power of 1 means itself, whatever the base is raised to that power. So we're going to get rid of that 1. So now x to the power of -2 over y to the power of -2, that's the same thing as saying 1 over x raised to the power of 2 over 1 over y raised to the power of 2. And now we're going to keep the 1 over x squared, and we're going to multiply it simply by flipping the second fraction, which is y squared over 1, which is y squared. So as a result, we're getting y squared over x squared. That's the final result. And it makes sense with this rule right here, right? Because x over y raised to the -m power is y over x raised to the m power. Because you can further take this square out by reversing this rule right here, and your result would be 1 over x raised to the power of 2. And that matches this rule that we have by flipping and then changing the minus sign by having a plus sign for the m. Okay, so I'll see you in my next video. We will talk about factoring expressions, polynomials involving exponents. Thanks for watching.